Dear learner, welcome to second session of sixth week. The theme of this week is smart manufacturing and intelligent manufacturing. In the first session, we have discussed the foundational part of smart manufacturing. What are the building blocks of smart manufacturing, and what is the significance and the advantage of smart manufacturing? All those aspects we have gone through. Now, in this session, I would like to go little in the deep that what is the framework of smart manufacturing, which are the key principles which make the manufacturing as a smart, and then we will also try to see some of the use cases, and all concept will be supported with some examples and depictions and pictures. And in this process, I will also be discussing the connected assets, connected plants and connected factories. Now, what is smart manufacturing? Let us revisit. Smart manufacturing focuses on digitalization and connectivity. We all know about digitalization and we know about connectivity. But when we say connectivity, what is the meaning of connectivity? In this session, we will try to examine that in next few slides. And the connectivity enables the factories to operate with the real-time visibility and optimize execution. Because factory is not one machine, it is a multiple factory is made of multiple machines, multiple plants, and different kind of processes are operating, and the connectivity makes a very big role, and all these plants and processes are connected, which we are going to see now. We are going to understand that how it is being done in the case of smart manufacturing. And the building block of the smart manufacturing is IoT, digital workflow, real-time data for monitoring and control. I will like to take a session this week on the real-time data, how the visualization works in case of smart manufacturing, and automated processes. These are some of the characteristics, but not all. And what is intelligent manufacturing? When smart manufacturing is supported with systems like software like AI and generative AI, we are able to generate the intelligence. We are able to do the forecasting. We are able to take very right decision as the human being take the decision. So machines start using these technologies, sometime to recorrect, sometime to decide what is wrong in the functioning of the machine. Is the product quality is right? If the market conditions are changing, how plants should adjust the production, the quality of the product. These kind of things are being done now in the latest factories, the new factories, in autonomous manner. That also we will try to learn in the next session. And as we know, as we have learned in the previous session, that AI, machine learning, all these digital technologies, they play a very important role for making the manufacturing intelligent. It is not limited, I will say, only AI and machine learning, but there are other technologies also play a role. Computer vision, augmented reality, virtual reality, digital twin. Digital twin is a very powerful technology to make the manufacturing intelligent. And we have discussed about digital twin in the fourth week. But again, let me see, we will try to revisit the digital twin in our fourth session. So this is what I thought I will explain in briefly about what is smart manufacturing and what is intelligent manufacturing. How they are interconnected? Smart manufacturing provides the foundation and intelligent manufacturing provides the brain. It decides that what kind of quality is required in the market, what are the anomalies happening in the machine. All these kind of decisions, the way our brain function is being taken on account of intelligent manufacturing, intelligent algorithms like that. So I don't want to go at this stage in a too much discussion. You yourself will learn as we go along. Key difference at glance: if there is a company or there is a factory which is not incorporated the intelligent manufacturing, and there is a company which is only following the smart manufacturing, which is the case in the large number of companies as on today, they will be using the technologies like IoT, digitalization, enhanced visibility, but they will be missing the latest derivatives or outcomes of intelligent manufacturing, like optimization of entire systems, intelligence driven operation like that, predictive and prescriptive self-learning systems. So these are the differences which, and one of the finest example which we find is the many companies which has been listed out by World Economic Forum, global lighthouses now are in the bank of intelligent manufacturing. And I will be trying to bring some of those examples in this session as well in the next session. There are certain requirements. I will say the requirements for smart manufacturing and intelligent manufacturing, and the connectivity is one of the important aspects. Connectivity and integration. As you are seeing in the picture on the right hand side, when we talk about the connectivity, we talk about the connectivity of the factory with the supply chain, with the R&D, with the distribution, logistic and distribution, and with all kind of connects with the government, compliances. Connectivity is a somewhat quite a wholesome approach. Smart manufacturing will not exist if we don't establish the connectivity of all entities of the factory or the manufacturing. So this is the basic, this is a fundamental requirement for a smart manufacturing. The connectivity has to be established, connecting machines, people, process, plant and product and partners. We will see further this concept, how it can be explored, it can be established. Industry today is a network, not a factory. There was a time when we were having factory in isolation. Now we can't think of a factory in isolation. We have, if a factory has to perform, it has to be a part of the network. Like factory is connected on the internet. Factory is connected on the side. Factory systems are connected with the customer systems. So this is also very important, that the factory of the future sits in the center of ecosystem, smart innovation, connected supply chain, smart distribution and smart building. Smart building is also important because today we are living in we have a requirement of green energy. So how green energy can be established in the factories, that is something which fall in this domain of smart buildings. Not only in the buildings, also in the plant also, the green energy. So and the government compliances, so that if there is any violation, your system should give the alert that this is something which is in violation, is non-compliance with the government requirements. So this is another very important concept. Industry today is a network, not a factory. And what is the other advantage of connectivity? Connectivity provides the visibility, real-time visibility. We can see the plant sitting at my home, sitting here, I'm traveling, I can log into my system and I can see what is happening in the plant. And that is possible only when you have a connectivity across the value chain. So market strategy, product strategy, forecasting, everything is possible unless you are connected. You connected. So this is also one of the fundamental requirement of, if you like to have the real-time visibility of the processes, which I will be discussing in the fourth session with examples, which there was system developed under my guidance, in Bharat Petroleum when I used to work over there. I like to bring some of the examples of real-time visibility, what was done in that system. So, this is one of the derivative of connectivity, I will say, the real-time visibility across all functions, all value chain. A very important aspect to make the success of the smart manufacturing is that horizontal as well as vertical connectivity. So, what do you mean by horizontal and vertical connectivity? As you are seeing in this picture, horizontal connectivity means that the functions which cater to the production in horizontal manner, like business model optimization, supply chain is a horizontal, smart logistic is a horizontal, security across all value chain is a horizontal, and when these systems or these are being connected in a horizontal manner, we achieve the horizontal connectivity. And that is what is companies who are establishing the smart factory, they are well aware of this fact, unless they horizontally connect their logistic and their supply chain and IT security management, because IT security management is not applicable to all system horizontally. Then if there is a problem in one of the system, then entire systems will stop functioning, will not be able to function. So, horizontal connectivity makes a lot of sense if we want to establish the smart manufacturing. We will see with some example which I have included in this deck, we will see that. Then we have every company today is having a bunch of softwares like CRM, product life cycle management, logistic, ERP, manufacturing execution system. This is a very special software which is required for the operation, to make the operation organized, to make the operation intelligent. The manufacturing execution systems, these are quite technical subjects, that's why I am not included in this deck, because it requires the prior knowledge of the plant, etc. And all these systems require the integration. Here we are going one step further, not connectivity, integration. Integration means that the system should be able to make use of their data. Next slide I have shown over there, the integration system. This is, if you see this integration, like IoT and sensors and field devices are on the bottom. They connect with the plant and connect the data through SCADA systems and PLCs. And then we have in between of ERP, which is a business system, we have a plant system called manufacturing execution system. Manufacturing system is also an ERP, enterprise resource planning system, for the plant, which have all details, what is the production in the plant right now, what is the anomalies are happening in the plant. One can see through MES what is happening in each and every unit of the plant. It's a wonderful system, and most of the companies who are quite vigilant about the optimization of their operation processes, they use the MES system. So, MES system is also very important part of I will say in most of the smart factories, but not in all. I will say, because most of the companies require production accounting and optimization of their inventory. Those are the part of the MES systems. That optimization of inventory is also part of the ERP along with the MES. So, this is what very important integration of system as a first technical step. Then we also require the vertical integration. What do you mean the vertical integration? Means if you see this this slide, here we are there are 4 layers I have provided over here. One is the IT layer, IT integration, because that is the cloud. We establish the cloud as a integrating platform. With the help of cloud, we are able to integrate systems. We have algorithm, we have connectivity for the integration, we have APIs for the integration, we have microservices for integration. Those technologies we have already studied in the 3rd week of our course. Then through once we have this integration, IT integration across the plant, across all business value chain, we should develop the analytics. And the fundamental principle for the analytics is that the data management should be perfect, which also we have discussed in the 5th week of our course. So this is very important, and once you achieve this, you are now on in the very right situation to achieve the operation efficiency. Operation efficiency means that whatever targets you have thought about your production, whatever targets you have thought about your safety, whatever targets you have thought about your quality of the products, those are being achieved with the help of these kind of softwares integration, this kind of analytics which we have discussed. So operation efficiency is also one of the objective of most of the achieving the operation efficiency is one of the key objective of most of the smart manufacturing companies, smart manufacturing plants. And the outcome of vertical integration, as I mentioned over here, is the real-time machine intelligence, predictive maintenance, and transparent processes. The important aspect is that once we have vertical integration, the processes become transparent. We can see that what is happening in each and every processes. How much dispatch is being done. Is there any problem in any of the processes, operation processes or the scheduling processes which may cause the problem in the production targets, etc. This is all due to the vertical integration. Very important point. We started with connectivity, then we have discussed about integration. Now the collaboration. The collaboration is also very important aspect in today's world. Like you have a sales team, you have the marketing team, and you have the R&D team who design and produce the new kind of products, recipes. So and logistic teams, these are independent teams, but we require a very cohesive coordination to achieve the goal of smart manufacturing. Smart manufacturing, and the best example of this collaboration is that we should have a dashboard, and using dashboard we should know that what are the sales target, how it is being achieved over there, what is the marketing, like that everything is being now reported on real time basis, which provide that the fulcrum of the coordination, So it is not something like manual collaboration and you are sending email or what, it is online on real time basis, all these functions are being collaborated. And we created a foundation for the collaboration. That is very important. The foundation, the digital foundation for the collaboration. We will see in the next session with some examples on this as well. So the collaboration between functions and products is another example which I am showing over here to emphasize that the collaboration is also one of the important ask for the smart manufacturing. So smart manufacturing, if you like to establish collaboration, is one thing which we have to establish. We have to use the collaboration technologies. So here for operation excellence, depending upon the type of the factory, type of your production requirements or type of the products. Sometimes there is automobile, sometimes there is a chemical. So requirements may differ factory to factory or business to business. So you have to set what will matter in your operation excellence. Depending upon that, we have to select the use cases. In this case, we say that predictive maintenance is one of the important aspect of our operation excellence, real-time process control, energy optimization, digital. So these are the things which will matter if we like to achieve the operation excellence in this case. That is what I am trying to show over here. And very important aspect which we know without data is the key asset of the business. If we don't have the data in such a way that it can be shared, it can be connected, it can be integrated, then we will lose this idea of smart manufacturing. So one of the important aspect, technically one of the important aspect is that we create a sound data management base. So that whatever is being developed, so it is everything is around the data. Everything is around the data. This is what very important to explore and to establish in case of smart manufacturing. And we will be learning this more when we will go on the fourth sessions of this week. And in this picture, I am showing that if you recollect that in the second week we have discussed about the process, business process value chain for Industry 4.0. So when you want to establish the smart manufacturing, we have to think about all processes of the company, and you are seeing over here the planning process PDP, then product life cycle management processes and customer relationship management processes. No, all these are horizontally integrated. So, and then on the left hand side you are seeing that the operational parts, like marketing analyst, product idea. So all these, these are also very important, rules, that I will not say these are the processes, but these are the rules to run your business, So they are also interconnected. They, one, like, if you have a product idea, then you will like to develop that product idea as a pilot, then once you have this available, then you will like to try this in the production, and once the production has been done, then you want to dispatch that. So these are all interconnected. So we have to establish this kind of connectivity, of our business functions, in a real time basis, so that one thing feed to the next, like that. Now the next picture is also little different elaboration of what I have explained in the previous picture. That here you will find that some management principles which are equally important along with the operation processes. You will find here that management, the sustainable management, management of external and internal relationship, all these things should also be the part of your smart manufacturing setup. So that is where the smart manufacturing differ from the conventional manufacturing. In the conventional manufacturing, we may not we try to do all these things manually, or not in the connected manner. But here, once you have the connectivity, like, and I give an example that suppose your CRM system is connected with your sustainable management of strategy development. So you are trying to make the strategy, and that what is happening in the customer site. So the development of strategy becomes the little more appropriate, a little more up to time. That is what will help in this case. So this kind of integration, this kind of collaboration, this kind of connectivity is one of the desirable function of smart manufacturing. Now, one or two examples I like to share here. You are seeing a picture over here. You can see that one company wants to have the smart manufacturing. First of all, they have developed a collaboration platform where you are finding the collaboration of predictive models. You can see the collaboration, different screens are there, and this is the operator which is sitting and seeing all this screen and seeing all this real time values coming on the screen, and they take decision according to, or they develop they will find in some of the cases there are alerts like KPI scorecard is also there, one of the screen. In that screen they will like to see that is there any fallout, is there any violations, or are we on the right path. This is all make the entire working in a collaborative manner, And on the right hand side you will see that what we have discussed earlier, that predictive and all this are the derivative. This become easier way of working of in all these areas like predictive analytics, information on demand, effective collaboration, and continuous optimization. So these are subject little on the depth, which I am not covering right now, but I thought I will give you a feel about that. Companies who are on the path of smart manufacturing, they have all this kind of systems in place. Then the next picture is a very elaborated picture which you can see over here. And here again these three principles has been repeated over here. Three key digital technologies enable the smart factory is the connectivity, intelligence, automation, and cloud scale, because data is very important. The cloud capture the data management is on the cloud. Data management is being done on the data which is stored on the cloud. So these are three very important aspects which we have to keep in mind, that if you like to set up the smart manufacturing, and you see the outcomes, the plant control tower, intelligent automation, these are some of the things which any smart manufacturing company will like to explore and like to establish in their company. Like Tata Steel, if you study the Tata Steel case study, you will find that most of these things are available in the smart factory of Tata Steel. Enhanced operator, Because here, when we say enhanced operator is a connected operator, and connected operator means that it not only is seeing the process on the computer or in his control system, but also he is being assisted with the intelligent systems like we have the Google Assistant, and in any situation he can start, he can take help from those kind of online robots, I will say online robots. That's why we call them enhanced operator, and this also we will learn in the next session about the enhanced operator. So this is a many picture. In one picture I will say any company who wants to make the smart manufacturing happening, they have to think about development of these kind of outcomes, like quality analytics, adaptive testing. All these things are the part of any smart manufacturing company. I am briefly touching about the framework. In the first session we introduced this framework in the last slide, and you can see that if you like to summarize what I have discussed, it can be represented, or it can be understood with the 3 layers of this framework. The first layer is called the attributes. Second layer is the kind of capability one company should develop to become the smart manufacturing or a smart factory, and which are the technologies we enable that. This is the third in the outermost layer. And very important thing, in the last 5 weeks, we have learned couple of technologies, couple of framework. Now in this smart factory sessions, we are seeing the implementation and the applied part of those technologies, applied part of those subjects. So that is what has to be kept in mind, and that's why I kept this session in the little later smart factory session. It become easier to understand that. Now let us explore these 3 pillars of connectivity in little more detail. Real-time connectivity we already discussed, intelligence we have discussed, connected we have discussed. And you can see that on the right hand side that this person or this supervisor, whosoever this manager is seeing on the real time basis the performance of his plant or whatever. And here with the help of this data and kind of algorithm this company is using, like Tata Steel deploy AI algorithm across 50,000 assets. The assets number may vary, but they have algorithms I will say anywhere, everywhere you'll find the AI algorithms, and as a result of that this company is able to has developed a very high predictive power in all of their operation, in all of the branch, and sometime I will say that they also taking autonomous. There is the word called automation and autonomous. Automation is an old technology. Autonomous means that with the help of technology, the machine itself is taking decision, or if suppose there is a minor problem, machine is correcting itself the way as a human being. Suppose we have a cold and cough, we don't take any medicine, and our body is having self-healing kind of capacity, and we in a 1 or 2 days time or in a few days time we become okay. Like that, every machine can be also have this kind of capability with the help of some technologies, so that they recover from their failures. So that is called the autonomous. And autonomous plants are there nowadays, very much there. And if you go through the global lighthouses case studies, you'll find quite a few companies today are running without many manpowers, and humanoids are has been deployed. Humanoids are the kind of robots which has limited intelligence to operate on machines without any guidance of any operator or any supervisor. They have their own intelligence to take the action. So humanoids are also becoming very, very common, and this subject humanoids we will try to explore and discuss in the 4th session of this week. Connected interoperability, which we have already discussed, is another picture, different kind of picture, where I have shown the connectivity of R&D and supply chain and how they are interconnected to each other. So these are the key capabilities. At the end, I will say any companies like to develop, but this is not all. This is a partial list. So this is just for your information. The enablers and enhancers, there is a little difference between enablers and enhancer. Enhancer means that the technologies which enhance the power of smart manufacturing to become an autonomous plant, no autonomous no way. They can have intelligence within the machine, within the plant, no. So that those kind of no technologies come under the category of enhancers, no. So like digital twin is one of the enhancer, digital twin, which we have discussed in the 4th week of our this course, digital twin. And horizontal integration and vertical integration help to achieve that autonomous status of the factory. Modularization is also very important aspect. So these are the enhancer we call it. I have taken this the concept from this global site iso.org. You can also visit this site. I will say that it is worth visiting and try to go a little more in deep of this subject. So friends, we have come to the end of today's session. In the previous 2 slides, I have just shown in little more detail about the horizontal and the vertical integration. With this kind of information, I hope that you will have understood that the connectivity aspect, that integration aspect, and collaboration aspect of the smart factory, and which can be deployed in such a way that factory become intelligent, and it start adopting the functionality of an autonomous plant. That is the dream of the future factories. That is the dream for the future factories. Thank you very much.